Hey everyone, let's wait for a few minutes. Hey guys. All right, let's wait for one more minute and then let's get started. We have a pretty full schedule agenda today, so let's get started early. Let's wait for one more minute. By the way, can you guys hear me? Okay, cool.
Yep.
Yep. All right, I think let's get started. So I share my screen, and this is the agenda today. We'll see how much we can get through today. We start from the top. Folks from Riot Game wants to discuss RAMFS or TempFS support, volume support, and this is the doc. what's your name? Like, I think like it might be great that if you guys can introduce yourself first.
Sure. Can you guys hear me?
Yep.
Okay, cool. So I'm Andrew. I'm a software engineer here at Riot Games. I'm working on a team trying to deploy a couple different database products in containers on Mesos. So one of the features that we're looking at adding is RAMFS, and we can talk about it more after Press introduces himself.
Cool.
Yeah, my name is David Press. I'm also an engineer here at Riot. Just working in the whole infrastructure space, been doing a lot of the work to get Mesos and DCOS set up here at Riot and get it integrated with all our infrastructure, deploy it. So, yeah.
Great, welcome guys. Yeah, let's get started. Do you guys want to share your screen, or you want me to just share the screen for you guys, and you just ask me to scroll down?
Yeah, I think this is fine.
Okay.
It's not a very big document, so.
Okay, sounds good.
Yeah. So we have kind of one very narrow use case for this. We're using the Mesos Containerizer, but basically we have a service that benefits greatly from having part of its files stored on a RAM-based file system, right? So kind of what we want to do is allow that thing to request a tempfs volume when it's in its app definition or task definition, and just get it provisioned. The way we're doing it right now is by using elevated Linux capabilities and letting it actually just do the mount itself, which we don't want to do long term because of the security implications of allowing that, and also it actually doesn't allow tasks in a pod to share the same RAM drive, which might be something we want to do in the future. So does that make sense?
Yeah, I think that makes sense. So one question I have is, like RAMFS use memory. Who gets charged for those memory usage?
Yeah, and that's the nice thing about tempfs is that you have more control over the limit, right? So the way I kind of envisioned this was, in your app definition or whatever, just like with a persistent volume, you would define the size in memory, and that gets added to the resource requirements for that task to execute. And so that task individually would get charged for it, but I don't know necessarily how easy or hard that would be to implement, right?
So I remember, if I remember correctly, that I think either RAMFS or tempfs, the first process that access the page will be charged for the memory usage.
Oh, interesting.
So I think, like, for example, like you have a container and you have a bunch of processes in that container, and you have a tempfs mounted somewhere, and the first process, let's say from container A, access to that RAMFS or tempfs. So that contains memory C group. So the memory usage for that tempfs will get charged to that C group that contains that process, if I remember correctly. But I'm not sure. Like, this is something that we should double check to see which container will be charged to the memory, because it's gonna go. I mean, if the memory usage get charged to some other container, then potentially you can own the other container. Because the usage in the RAMFS or tempfs memory usage. So that's one thing that we should figure out, definitely.
Yeah, absolutely.
I think, yeah, I like the direction. I think like one way we can do is like, that's something kind of related to the second agenda item that I recently did the cleaning up of the volume documentation. I think one natural way to do this is just like adding a new volume source called tempfs or RAMFS, and in the container info, and then that will just be mounted inside the container, and you have an isolator to do that.
Yeah, so I did actually prototype this a little bit in a fork, and it's not. I wouldn't say it's like merge ready yet, but that's basically what I did. I just added a new source in the container info and.
Okay, yeah, I think that sounds like a good direction for now. I think in the future, like we do want to like we do want to account for the memory usage, because we do have uses where like two containers wants to share the same RAMFS. We do have that use case. I think if I remember correctly, either like Aluxio or something else, like there's some like a RAMFS based acceleration scheme in Spark. There's a company doing that, and their requirement is like multiple containers can share the same multiple, for example, multiple tasks or multiple executor can share the same RAMFS. And for that to be working properly, we need to have some way to translate the memory resource to disk resource, basically. I think that probably need the resource provider stuff that we are building right now. But that's kind of like not something that we need to do immediately. I think the immediate thing is like adding a new volume source. Sounds good to me.
Cool.
Okay, any other comments on this? Okay, so okay. Yeah, for Windows, I don't know. So anyone knows like there's any like TempFS or RAMFS equivalent things on Windows? No?
I'm not sure. We don't need it for Windows, but I didn't know if other people might, so that's why I threw that in there.
Yeah. Okay. So Docker containerizer. Like, what should we do if we want to support that?
So I mentioned lower below. Docker has a TempFS flag in the Docker daemon that actually does just basically do the same thing. It would still be specific to each individual executor. It wouldn't be shared across executors, or at least that's how I understand it. So if we wanted that, we would have to have just a regular like mount at the Docker level, and then create the TempFS outside of it, right? But
I see. Okay.
Yeah, like I said, we're not using the Docker containerizer, so it's not something we looked at as hard as we looked at the Mesos containerizer.
Okay, so it would be great that you can like fill in the port above. Like I'm curious, like where do you specify the size of the TempFS volume or MFS volume?
Yeah, and the one I have right now, I just put it in the like container info.
The volume source or container?
Yeah, sorry, the volume source inside the container. So, yeah.
And the size of that TempFS volume is part of the message for the TempFS. Like there's a TempFS message. Okay.
Yeah.
Yeah, it would be great. Like I think what we should do is let's put the port above, at least the API in the doc, so that everyone knows like how to use that API.
Okay, cool. Yeah, I can throw it in there.
Yeah, and also I think like do some research on the who gets charged for the memory. I think that's pretty important to get that information.
Yeah, absolutely.
Okay, that was my only 2 comments. I think the whole thing looks good to me. Any comments from other folks? No? Okay, that sounds pretty good. So yeah, let's do that. So I guess the question is, who's going to shepherd that work? Who has the cycle to shepherd this work? Okay.
If no volunteer, I can do it.
Okay, yeah, that would be great. So thanks, Gilbert.
Yep.
Yeah. Okay, cool. Anything else from you guys? No? Okay, so sounds good. So let's move to the next one. We have a pretty big agenda item today. So okay, I want to talk about the documentation cleanup and that I recently did as part of the hackathon project during Mesoscon. And I also need some help from you guys to adding more documentations. So let me share let me go to the current documentation, just show you guys like what I did and of how you can help. Because I think one thing that we don't do very well previously was the documentation, and I think we should improve that. So here is what I did. So it used to be like there's one single page has a subset of the isolator documentation. It's not a full list. And people don't know how to use those isolators in Mesos Containerizer. So what I end up doing is I have this file being an index file and have a link to each individual isolator documentation. We do have a bunch of isolator documentation for things like, for example, NetCLS. If we go to this, we do have some documentation for that, but we don't have the documentation for some of them. For example, we don't have documentation for file system isolator. We don't have documentation for like volume image. So that's something that I kind of want you guys to help with. Like if you can, if like, for example, like if you're the owner of, for example, volume image, I think or this Gilbert, you, that it would be nice to have some documentation and update this doc so that we have a full doc for every single isolator that we have right now. That will be super helpful for the community.
Yep, I will add it.
Yeah, that sounds great. I think like some of the like isolators are kind of legacy that we prefer don't have owners, like for example POSIX ones, but those are going to be pretty simple. I think I can own this file system Linux because I think there's quite a bit like logic there, and I'm quite familiar with that. So I'll take an action item to update the doc for that. We need some help for the C groups ones, especially block IO. That I believe we do add some functionality into block IO stuff, especially getting the stats, but we do not have any documentation for that.
I'll volunteer for that since it came from our company.
Okay, sounds good. Thanks, Zhitao. So yeah, Zhitao is going to work on the. Anyone take notes? So Gilbert is going to work on the volume image. G is going to work on file system Linux. So Zhitao is going to work on the C groups block IO. Okay, so that's a good start. Anyone volunteer for the rest of the isolators? I think like I think Halstan is the one that did the refactor and adding those support. I'll ping him, see if he can add some documentation for the rest of the C group. And for device, I'll ping a different guy because I think he did some change and there's some undocumented behavior. So G will follow up. C group devices. I think like the guy from Douban is the guy that did some change on this. Okay, so that's
with other C groups isolators.
Sorry.
I can help with other C groups isolators.
Oh, cool. Okay, that sounds great. So Ilya will have. Okay, sounds great. So let's go back to this list. Gilbert, do you have time for the AppC runtime?
Yes, I can do it.
Okay. Okay. Anything else? File system Windows. I think this is from Microsoft. Is there any guy from Microsoft on the line? Okay, so no, I think I'll ping Andrew on this. From Microsoft, who did that. Yeah, I'll probably handle POSIX too as the same thing. Okay, and these two are trivial. I'll probably just do that. Okay, that sounds good. I think we have everything covered. Great. Okay, these are the isolators that we did. I think the other one is volumes that I recently did. If you go to container volume, that's a new documentation I add. So right now we have 4 source types: host path, sandbox path, Docker volume secrets. I think I added documentation for host path and sandbox path, and I think we already have documentation for Docker volume and the secret. So I think that part is pretty good. So so Andrew and David, I think like once you add the temp.fs or ram.fs here, so you need to update the documentation for the new source here and adding documentation. I will probably split into a separate doc so that I have a link here. Yeah, I think just give you a heads up on this documentation. This is something that we did recently. I think like we should have done that like a long time ago, but due to several reasons, we don't do that. But I think like we should keep updating the doc once we have time. That's pretty important. Okay, so that's pretty good. So the third thing I want to discuss. Oh, by the way, folks, if you have any agenda items, feel free to add to the doc. I add a bunch this week because I think there's a lot of things going on. So the next thing I want to discuss is system D integration. So I'm not sure everyone familiar with what we are doing right now with regard to system D. So basically what we did right now is it's pretty hacky, and it's not great, especially when you go to like a box you want to see, like for example, using system D C group, CGLS or CG top, you won't be able to see those C groups managed by those container managed by Mesos. The reason for that is right now what we did is we essentially put all the process into a single slice called Mesos-execute.slice that contains all the processes from the containers. We don't split into multiple services or scopes. So the reason we need to do that is this ticket, I think, not this ticket, sorry. Not this ticket. So we used to have a bug where systemd will migrate your processes because the hierarchy you saw in the name systemd hierarchy is different. So name systemd is a C group hierarchy that used by systemd exclusively. It's a name C group hierarchy. So so basically systemd will look into that hierarchy and find out all these units inside that hierarchy, and trying to do a sync with other hierarchies like CPU, memory, and block I/O, things like this. And because of that, it will try to migrate PIDs if it didn't see a corresponding unit or slice or scope inside the name system DC group. So that's the bug previously. If you want to like look into more details, I think there's a reproduce steps that you can do. I think yours did the change at that time. And to bypass this bug. But the way we did that is pretty hacky, and look at the implementation like this week. And what I actually want to propose is this ticket. So basically, like what I propose here is like we try to do similar to what Docker does right now with their C group FS C group driver. That we will create C groups under the name systemd C group hierarchy, and put the PIDs into the corresponding C group, like sysfs C group systemd, and then we create the Mesos, and then we adding container ID as subdirectories under Mesos. So that like the benefit of that is at least you can do C group ls to list containers, and do C group top to show stats for Mesos containers. Another benefit is I think that's an internal request from us that we want to run Kubernetes on Mesos, and Kubernetes has a very weird check that to make sure that do the check on the systemd C group. So that will allow us to pass that check as well. So that's kind of the motivation. I want to hear some thoughts, comments on this, any concern on this. Anyone has any experience on that? Okay, so sounds like yeah. Let me know if you have any comments on this approach, because I do believe this is the better way of doing things rather than just jam everything into a single slice and then you don't get a way to see all the containers under those systemd commands, and you don't see the resources. The resource accounting is not correct if you're using systemd tooling.
So hey G.
Yeah.
So this change, will it break some existing running containers?
No, I don't think it will break. So all the existing container will be part of the original Mesos execute slice. So we won't change that. We won't try to migrate that. So the new containers will be put under this new hierarchy. Like for every new container that launched by the new agent, it will be under like /mesos/ the container ID in the systemd named hierarchy. So the old one's still in the old like Mesos-execute.slice.
I see.
Yeah, it should not break we probably need to still keep some check previously, but I think it's doable. Just like to make sure like the old container behave as it is right now, and new container will be under this new hierarchy. I think that should be fine. Yeah, I think the only thing I chat with Joris, who wrote this original hack yesterday. I think one thing we should do is adding more checks in the code to make sure that because he's still worried about the migration, because honestly the system D code is not that readable. Like I tried to read the code, I know like what they're trying to do, but I'm not 100% sure because the code is like not that readable. So he's kind of a little worried about whether we fully understand the system D behavior. So what I will plan to do is adding some checks in the code to make sure that whatever the for a given PID inside a container, I want to make sure the C group for the name system D hierarchy are in sync with the C group for some other hierarchy like CPU and memory to have some check like this to make sure that the PID is not migrated by system D. So if there's a migration happening, we will notice immediately. So that way we are confident that in this way we don't have a migration issue that we discovered previously. But I'm pretty confident this should be the case because that's what Docker and Kubernetes does right now. So if there's an issue for that, I mean there should be some ticket. I searched a little bit online and I don't find any relevant ticket for the migration issue.
G, what versions of Docker did you test?
Let me double check. I think I'm using 1.13.
Because that's not the behavior I see on my Fedora box.
Yeah, I think like depends on which cgroup FS driver you are using.
Okay.
So I think if you're using systemd driver, then all the cgroup is going to be under like a docker.services. Okay, let me share my screen.
Yeah, okay. So I'm using Docker 1.31, and on the command line it says it's using cgroup driver systemd. And the behavior I see when I run a container is it creates a Docker scope within system.slice for a specific container.
Okay, which version is that? Sorry, say it again.
1.13.1.
1.13. Let me check my Docker version. Okay, so my Docker version is 1705 and community, like CE community edition. Sorry, I think like mine is a newer version than yours.
Right. Maybe they changed the behavior.
Yeah.
But at least it looks like from where I'm sitting, they put it in a slide. They put it in a scope, and then systemd CGLS sees it under system.slice. So whatever that's worth.
Okay, so can you guys see my screen? See my terminal?
Yes.
Okay.
Oh, I did a different Docker version command. Yeah, it looks like they've changed the behavior of that. G, do you know that you're muted?
Oh, sorry guys. I said a lot of things. Yeah, so what I'm saying, like, do you guys have any like comments on this? I also mentioned that, sorry, I speak a lot. So I also mentioned that that the side effect of this change is like one nice side effect of this change is we now should be able to support like a running Mesos agent in a Docker container. So previously there's a kind of like a blocker for that support is because we don't enable all the seed name, we don't enable all the hierarchies and that Docker supports, and that caused me issues. Now, once we have that support for systemd, then we essentially like on par with Docker, so that we don't need any code change to be able to use like a Mesos agent in a Docker container if we want to. I'm not saying that we suggest that way, but it's possible now with this change.
So to follow up on that, does that mean all the C groups related isolations, as long as the Mesos in Docker container is enabled in proper privilege, the Mesos containers that's launched from this agent will see them?
Sorry, say it again. I don't follow the question.
So can you clarify, like on the isolation part, does this mean if we run the Mesos agent in the Docker container, and this agent further launches any native Mesos containers using unified containerizers, does that mean it can utilize things like CPU or memory C group?
Yeah, it will be the full function of the agent, so it shouldn't be any difference than like running agent on bare metal. So it'll be the same functionality, and also I think that the previously the kind of the blocker is like after the Docker container crashes and the restart agent, there might be some pip being migrated Docker will like trying to kill, because I think Docker rely on the C group information inside its name, the systemd hierarchy, which we don't support previously. So they will try to kill those containers, and with this support, then it should be. We should be able to handle that. There's some configuration you have to do, especially for some directory that Mesos wants to use, like varlib Mesos, varrun Mesos, and you want to make sure those are share mounts. I think besides that, once you do the configuration right, then it should be able to handle. It should be able to run agent inside a Docker container.
What about running Mesos agent inside Mesos agent? We have a lot of demand on that for continuous testing purpose.
You mean a full function Mesos agent?
Inside another full function Mesos, inside the physical Mesos agent.
Yeah, that's something that we can explore. With this change, it will definitely make that easier, but I'm not sure if there's any other things that we haven't thought about if we want to do that.
Great, we're looking forward to this.
But yeah, at least this is like one step closer to that goal, I would say. Mm-hmm. Cool. Any other questions on this? No? Okay, let's move to the next one, the final one that we have today. Okay, so the context for this one is I got some feedback. I was at Open Source Summit and also MesosCon last week or the week before last, I think last week. And I got some feedback. So certain people asked me that when is the VM support in Mesos, especially Mesos Containerizer. And the reason people asking for that, one is because I think Rocket supports Intel Clear container. And also I think for some folks that wants to achieve true multi-tenancy, like container itself is not that secure compared to virtual machine. Like if people are very worried about the security, like if you want to have a true multi-tenancy, like for example, public cloud, then having a virtual machine is more desirable than having containers because the security that it provides is much stronger than a container, which basically all the containers in the same machine share the same kernel. So the trusting computing base is much smaller for virtual machines. So that's like several people asked that IBM support. That's the reason I want to start this discussion and at least some background research. I know like there's some stuff like I think there's some previous attempt on supporting VM on Mesos, and I know like some people using a different way to do VM support on Mesos. Basically the Assecure based way, like Assecure launching virtual machines, and Mesos is not aware of those virtual machines. So, but what I want to achieve here is that we can launch virtual, like basically like the framework can just give a container image or a virtual machine image to Mesos, and Mesos can just launch that container or that virtual machine image using a virtual machine. So if it's a virtual machine image, then you will just launch that virtual machine. If it's a container image, then we will launch a virtual machine, and then inside that virtual machine, we'll launch that container. So that's kind of the goal I want to achieve. And we have a lot of like background research needs to do. So that's the reason I want to call out here, like see if folks have time to help on this. Or like if there's any interest from other folks, like what we are missing here. So I create this doc. I kind of list all the, can you guys see my screen?
Yes.
Okay, so yeah, I create this doc. I think the first step for us is trying to do a thorough like background research on like what's the state of the art, what people are doing right now, and is that right or is that not right, and what should we do? So that's basically like the first step I was thinking. So we have a bunch of tickets for those VM support, like it dates back to like 1A1. That's like for like 5 years ago, I think. I don't know. Anyway, so I think like we have a bunch of related work. I want help from folks to do research on that. Like I know like there's a KVM, there's Intel Clear Container, and there's Hyper, and Rocket has VM support. Kubernetes has VM support. I put some link there. I think JP also put some links there. And then there's some cloud providers like EC2, GCE, Azure, and also we have OpenStack. So there's a lot of things that we probably need to do some research for. And I think we definitely need some help from folks. Yeah, we do have a previous design doc for this. We need to go back to that and see what's being changed and what should we do. I think the goal, I don't want to introduce yet another containerizer if we can avoid that. I think that's one of the goals that I want to achieve as well. Like I don't want to introduce because maintaining like several containerizers is super complex, and it's not like a maintainable future if we have so many containerizers. So I want to see if we can have VM support inside Mesos Containerizer if possible, so that we can maintain less containerizers.
So well, I guess one thing I have to say is if your design goal is running containers inside a VM, that's a pretty different design goal than running VMs in general, right? So I think once we get through the related work and the research, I think the set of use cases we choose is going to be pretty important for how this gets designed.
Yeah, I think we can delay that discussion later. I think the reason I mentioned this is because I took a look at Rocket's VM support. I think that's what they did. I think in some sense it makes sense. Like for some people, like I just want security. I have this Docker image. I just want some security, like more level of security, and running that inside the VM kind of makes sense to me. But that's the reason I mentioned this kind of this point. But yeah, I think we can do more discussion once we have the background done. Yeah, I agree with you. We should do that later rather than here. And now we should do more research on some of the stuff. Okay, any comments on this? I'm curious if you guys have any like a requirement on virtual machine support.
Isn't that the use case discussion?
Yeah, I want to collect some use cases as well. Like I just want to make sure like we're doing this something for. I do hear some use cases during the conference, but I want to hear from you guys. Do you have some internal like requirement on that, and what are the use cases you guys want to do with VMs?
So I've heard at least three different use cases. First is running a container inside a VM for quote improved security. The second is running a VM as part of a container for privilege separation. So you have a task, we have a containerized task, and that containerized task wants to privilege separate something, some untrusted portion of itself, which it runs in a VM.
Okay, so let me try to understand this. So you're saying like running a VM as part of a container for privileged
for privilege separation. So this is the case where you have some kind of task which is maybe executing some user code or some Lambda function or something like that, and it doesn't trust the user code, so it wants to privilege separate itself from some sort of other part.
Okay.
The third case is just running a VM that's running a actually different OS, so running a task in some non-Linux US operating system.
Okay. Okay. Any other use cases? That's great. I think that's a great start. Yeah, that precisely captures some of the like use cases that I heard from the open source summit. Okay, so running a VM with different guest OS as part of the privilege separation, and for security. Any other use cases that you guys can think of?
So I would think about network function virtualization, NFVs. So a lot of the NFVs require a much newer kernel to run things like eBPFs, right? And so when you want to run containers with a newer kernel, this might be the way to go.
Okay, so that sounds like similar to with a different guest OS kernel.
I'm not exactly sure it's the same. Simply because you might give your own image, Docker image, but you might just want to use a different kernel, which is what Intel Clear containers and all can do, right? You can just give it a kernel image and it'll just run that particular Docker image with that kernel image.
Yeah, I think the NFV case is almost a subset of running the different guest OS. Like you could implement NFV with KVM tool, for example.
Yep.
Because it's defined to be some version of Linux.
Yep.
But you can't implement a different guest OS with KVM tool. So I think it's worth. What I'm saying is, I think it's worth breaking it out as a separate use case.
Yeah. Okay. Any other use cases? That sounds great. That's a great start. Any other use case? Okay. So I think that 4 use cases is good enough for us to dive into this thing. I think especially for security, like multi-tenancy. Is pretty important. Okay, so I think like we have a bunch of systems that we want to research. I want help from you guys. Like anyone volunteer for like doing some research. I think the goal is trying to populate this doc. Like just write what you discover for that thing, and how can we potentially integrate with things like KVM, Intel Clear Container, like what they're doing right now, what's the background, and what other people are doing right now, and just focus on like what they're doing right now and what's the new thing they're doing, and how potentially we can integrate with that thing. Like focus on these 3 things. The goal is trying to like just write this doc, and once we have the full background, and we can have another sync and see what we can do from there. And I think producing a doc itself is useful for us to reference to, and we can probably copy some of the stuff from the previous design doc, something like this. Anyone volunteer to help on this? If you have time, we don't have a strict timeline for this. Like if you have time, feel free to. I mean, you can help at any time. I just want to like say if we can distribute the workload, like one person focus on one thing, that's more efficient, maybe. Any volunteers?
I'll probably spend some time on it.
Okay, so I mean, so James, I think like which one you want to focus on, like doing research for. I think like let's distribute the workload. Like,
I don't know that I want to commit to a specific one. I'll probably just write some more text around the use cases to get some more detail there.
Okay.
I don't know which one I'll specifically look at.
Okay, that's fine. I think what I would do is I probably do some research on the Rocket support, because that's like a very interesting existing support for. So I'll do some digging on this one, Rocket support for VM. Because it's kind of related to container and also virtual machine is very relevant. So I want to do some research on this one. Anyone like interested in like Kubernetes VM support? Like who is familiar with Kubernetes here? Anyone?
I can try helping out with the Intel Clear containers. I have some contacts with the people who develop the Intel Clear containers. Let me try and get some info from them and debug it myself as well. I was just interested in that. What is the time frame we are looking at over here?
We don't have a straight timeline. I don't want to put the timeline for this. I mean, I think like let's try to shoot for like a month for this.
Okay. All right. Sounds good.
Like in a month, I will schedule another sync. Maybe like during the working group, we can do a sync on this and see what's the progress there. I just want to get this thing started. If we don't do that, then it won't get done. So
sure. Yep. All right.
This is a very good first step. Thanks, Avinash. Any other volunteer for maybe? So James, you mentioned you will do the use cases. Okay. Yeah. So for Kubernetes, I will ask some folks that are familiar with Kubernetes, see if they can fill in like some stuff for us. And Hyper and KVM. I think these two are very related. KVM, Intel Clear Container. That's pretty related.
I think the Hyper might be related to Kubernetes support.
Oh yeah. So yeah, it definitely is related. I know they have an integration, but I mean, yeah, okay. But I think like for this support, like we are more interested in like how do they integrate with container, because Kubernetes is a container orchestrator, but they do support VM. I'm curious like how this thing play out. For Hyper itself, I think like they have a lightweight virtual machine. I want to know like the details. How do they support lightweight virtual machines? How fast it is compared to other solutions like KVM or Intel Clear Container. Does that make sense? So Gilbert, can you help with the Hyper thing?
Yes.
Okay.
Yes. And I can also reach out to the UCAL guy to ask them for more context, because they already implemented VM support on their framework and executor. So I guess they're using KVM, but I think we can ask them for some input here in this stuff.
Okay, yeah. So let me do this. So Gilbert, you're gonna reach out. Well, it's not preview design doc. I think I know like we have some integration like uCloud uses VM with Mesos Lean executors. Yeah, I mean, nice to get some detail on this. Okay, sounds good. Thanks, Gilbert. Okay, so I'll probably like if no one do KVM, I'll probably do the KVM too, because I'm also interested. Let's do this. Okay, I think that's a good start. Thanks everyone. I think that's a very good start. Let's shoot for like a 1 month check on the progress of this one, and go from there. Okay, so that's it for today's agenda. Anything else that people wants to add to the agenda, or you want to discuss? Anything else you can discuss here?
Oh, so one thing we might get some feedback on is ordering of isolators. So I guess we chatted briefly yesterday on the containerization channel. So currently the ordering of isolators is undefined, but it's documented as being the operator order. My view was that requiring operators to know what the correct order is too onerous. Like just having a lot of isolators already is already too complex, I think. So yeah, telling people, oh, you have to get the ordering right is also too complex. But looking through the Git history, it looks like we've been down this path before, because the patch I came up with was extremely similar to some previous work that Kevin Clues did. And it, like, going through the history, I have like pretty close to the same code. So do we really what do we really want to do here?
So what? Sorry, I don't get the context. Like what Kevin Cruz did previously.
So previously, there's Kevin Clues changed the isolators to apply in a internally defined order.
Okay, and why this change is not merged?
It's not that clear. It was merged and then it was backed out and the reason given for backing it out was because it's supposed to be the order defined by the operator.
Okay, so do you have a link? It would be nice if you can send that link. I'm not aware of that thing.
I think it's Mesos 5118.
5118.
I think.
Yeah, I remember there was ticket.
No, some combination of fives and eights. 5581.
5581. Yeah. So who gave the feedback on like why it's being backed out?
It got backed out by Ben Marler.
Okay.
Eventually, but basically the reason given is it's supposed to be ordered, but it's supposed to be done by the operator. But there's not really any indication of why the operator really has to do that.
Yeah, I think what we really need to find out is there any requirement? I think like for internal ones, for sure we can do that. I think the tricky part is like for custom modules that if there's ordering dependency between custom module and the building isolators, like if people have that dependency or not nowadays, if there's no dependency, we can just do that and just say that all the custom module will be executed after those building modules. But if there's a dependency, we need to figure out a different way. So I would say like let's start a thread in the dev list and just asking, we should do that in the user list. Just asking for people if people have dependencies on their custom isolator module with building isolator modules.
Yeah, I'll get my patch out. Once I have that out, then I'll send something around.
Yeah, send out I doubt there will be any. Yeah, it's very unlikely that people will have that dependency. And I think like another goal we're trying to achieve is like somehow like maybe in the future we don't have that dependency anymore. Like, is there a way to get rid of that dependency? Or we should have less dependency if possible, to be honest. But I think that's a separate discussion.
So James, you are proposing this. Does it comes from the ticket 7643?
Yes, because I think that one was about returning to order, like applying them in the order specified by the operator. So once I started looking at how to do that, it seems hard because we have these sort of weird partial ordering constraints that we check.
Yeah, so right now we have some, if I remember correctly, we have some special logic to always put the Linux file system isolator as the first one, and always put the GPU isolator as the last one in the dependency. So if we want to allow like operator to specify the sequence, how we launch the isolator, so some of those isolator will not be it's hard coded in containerizer, so it cannot be defined in the order from the operator side. So it sounds a little weird to me.
Yeah, I agree. And we have things like we implicitly add modules too, right? We insert the network CNI. So as soon as we insert network CNI, well, where should we do that in the ordering if the ordering is, fixed by the operator? None of that. So all these things that we manipulate with the way we load isolators kind of violate that goal.
So James, yeah, I think I'm all for this change. I just want to make sure like it didn't break existing users. That's the only worry I have. I hope not. And if not, then we should just do that change. I will simplify the operator's job and also like it will simplify code as well.
Yeah, I think just doing it right is the right thing. I just don't want to go back around the way. Let's do it and revert it cycle again.
Yeah. Okay, yeah, let's just do that. I'm all for this change. It will simplify the operating in the code. Any other thoughts on this?
Sounds good.
Okay, so the action item is James will send an email to user list to ask for feedback. Okay. Sounds good. Anything else that people wants to discuss? Okay, no? I think if no, then that's it for today. Thanks everyone for joining, and have a great day. I'm gonna post the recording to the dev list. And thanks everyone for joining. Thank you very much. See you guys.
Thanks, guys.
Yeah.
See you guys. Bye-bye.
See ya.